This is Geometry, Day 2 for Unit 6. We're reviewing some of our thoughts about dilation. We know that a dilation is a type of transformation that reduces or enlarges a figure to create similar figure. In a dilation, a figure is shrunk or it is enlarged with respect to the fixed point called the center. So a dilation makes the image bigger or it makes it smaller. The scale factor is a ratio of the side lengths of the image to the corresponding side lengths of the pre-image. I often call that the original. So you could say that K, which is your scale factor, is equal to the image over the original. You can describe a dilation with respect to the origin with the notation of x comma y turns into kx comma ky. You're going to take your scale factor, which is k, and you're going to multiply it to your x and y coordinates. If the k value is between 0 and 1, you're going to get a reduction. If the k value is greater than 1, you'll get an enlargement. So the figure will get larger if you're multiplying by a number bigger than 1. It'll get smaller, of course, if you're multiplying by one less than 1. So in example 1, we're going to start out with plotting our points. 2, 0. So that's A, B, C, and D. Now we need to figure out where are the new coordinates going to be after the dilation. You always need to know what your scale factor is. The scale factor in this case, use a scale factor of a half. So we're going to take our rule, we're going to multiply the x by a half, and we're going to multiply the y by a half. This is going to do a dilation with the center at the origin. If you're ever multiplying your coordinates like this, it's always from the origin. So we're going to take our half and multiply it to the 2, and then we're going to take our half and multiply it to the 0. So that's going to give us an L of 1 comma 0. We'll take our half and multiply it to the 6. We'll take our half and multiply it to the negative 4. That's going to give us an M value. We're taking half of the 6, so that's 3. Taking half of the negative 4, so that's negative 2. Half of 8. Half of 2, so that's going to give us an n coordinate. So half of the 8 and half of the 2 gives us 4 comma 1. And finally we'll take half of the x and take half of the y, because half is our scale factor. So the p coordinate is now going to be 3 comma 2. So we can go over here at 1 comma 0, 3 comma negative 2, 4 comma 1, 3 comma 2. So this was L, M, N, P. Show that the corresponding sides are parallel. To do that, we're going to look at our slopes. Slopes that are the same will show parallel sides. So I'm going to take DC and its corresponding part, DC and PN. So DC goes down 2 over 2, so it has a slope of -1. PN goes down 1 over 1, so it has a slope of -1. So they are parallel. I showed that the two corresponding sides were parallel to each other. AD and LP, their slopes are going to be up 4 over 4, which is a slope of 1, up 2 over 2, which is a slope of 1. So again, these two sides are parallel. I'm showing that they're parallel to each other by showing the slopes are the same. BC and MN, BC goes up 6 and over 2. And MN goes up 3 and over 1. So again, the slopes are the same. AB and LM, AB goes down 4 and over 4, so a slope of -1. LM goes down 2 and over 2. Again, the slope is -1. On the next page, this is page 6 of our notes, we're going to graph triangle ABC with these coordinates. So we have A, B, and C. Then we're going to use a scale factor of 2. They need to tell you the scale factor, or you need to have enough information to calculate it. So they give us the scale factor of 2. So now we're going to come over here and multiply each of these coordinates by 2. So 0 times 2 is 0. 0 times 2 is 0. 4 times 2 is 8. 0 times 2 is 0. Times it by 2, and times the y by 2. So those are our new coordinates. So we'll come out 8, 6, 4, and then of course 0, 0. So this is point F, point E, and point D. So we're going to show that the sides that do not pass through the center are parallel. What sides of our figure are not going through the center point of dilation? CB doesn't go through the center point, and neither does FE. So CB, the slope of CB is down 2 over 1. The slope of FE is down 4 over 2. So again, the slopes are the same, so that is showing that they are parallel. What do we notice about the other segments? We notice that the other segments that they are both containing the same endpoint, which is the center. They are extensions of the original segments. So extensions doesn't have T in it. You are making your own photo. You're going to have the original, which is 8 by 10. You're going to have the image, which is 2.8 by 3.5. What is the scale factor? When we calculate scale factor, we do image over original. So we're going to take the image and the original. So we're going to take 2.8 divided by 8, and with our calculator we can see that that becomes 0.35. And the other corresponding parts, 3.5 divided by 10, those two pieces are corresponding to each other. The longer segment's going to come from a longer segment, the shorter from the shorter. When you divide by 10, you move the decimal spot over 1, so that also is 0.35. The scale factors have to be the same within the same problem. Number 4. You want to create a quadrilateral, JKLM. So JKL, what we don't know is where M is. M is located somewhere out here. We want it to be similar to quadrilateral PQRS. So I'll trace out PQRS. So there's that segment, or figure. And then we have our other one, and we don't know just where it's going to be drawn to. What is the coordinate of our missing point? Our point is M that we don't have. Well, we first got to look at our scale factor. Look for your scale factor. Your scale factor, you're going to look for an image over original. Two values that you know that you have. You can do distance, like 4/2, or you can do actual lengths, and that's what I suggest you to do. Look for lengths that are vertical. Here we have a vertical length of 4. That's our image, KL, over QR. So that's going to be 4/2. So our scale factor is 2, and that's called K. So once you have your scale factor, you're going to take your coordinate S, which when you count over 5 and up 5, to figure out M, M is going to be your scale factor times 5, and your scale factor times 5. 10, 10. So that's going to be 9, 10 over and 10 up, right about in there. So there's your new shape. Last question. You want to create a quadrilateral QRST that is similar to WXYZ. WXYZ. So there's your original shape. Your image is here. We have an additional point that is floating out here somewhere. So we got to figure out where that point is, because we need to figure out the length of S to T. But I don't even know where T is located. So one way we could do that is to find out what corresponds to ST. YZ corresponds with ST. So if we knew what the length of YZ was, and we can do that by the distance formula. So the Y coordinate is over 2, the Z coordinate is over 4, the Y coordinate is up 2, the Z coordinate is up 6. So that gives us -2 squared and -4 squared, which is 4 plus 16. So that's going to give us the square root of 20. So now we know that YZ is this length called square root of 20. It's a little bit more than 4 and a little bit less than 5. So what we need to do now is to figure out if that's the length. If I knew something about the scale factor, then I could multiply this length by the scale factor. Find the scale factor. So to find the scale factor, I'm going to take my image over original. So two values that I know, I could either use distances or I could use segment lengths, and I suggest using segment lengths. My image is SR. That's an easy one to count. And also YX. That's an easy one to count. I can't count a slanted length. I can count vertical or horizontal. So we have 5 over 2, which is 2.5. So for us to figure out the length of ST, that's going to be 2.5 times the square root of 20. So that's my actual answer, which is approximately 11.18 units. That's how long that would be. That's not telling me where it was located. That's just telling me how long that segment is. That's what they've asked for here. They did not ask for the coordinate of T. They asked for the length of ST. The length of ST is 18.18. 11.18.